So today we're going to solve single variable inequalities. We're going to represent their solutions on a number line, and we're also going to recognize when to reverse the inequality sign. So when we solve single variable inequalities, it's the same idea as solving an equation. Our goal is to isolate the variable. But as we just saw in the Nearpod, there's one new rule that we need to remember, which is that if we multiply or divide by a negative, we have to reverse the inequality sign. So if it was greater than, it would go to less. If it was less, it would go to greater, and so on. You're just going to flip it around. So let's solve a couple and see what happens. So on example 1, my goal is to get y isolated. I can see that y is being bothered by 7, and it's being bothered by division. That means that to undo it, I'm going to multiply both sides by 7. Now remember, I like to show it on the side to show how these 7s will actually cancel out, leaving y by itself. Now in this case, on the other side, I have a negative 4 times 7 for negative 28. Now you might think the inequality sign is going to reverse because we multiplied a negative, but the number we're multiplying by is 7. So since that number is positive, it has nothing to do with whether or not this number is negative. My inequality sign is going to stay the same, and so my solution would be y is greater than or equal to negative 28. If I were to graph this in a number line, I would graph it with a closed circle to show that I'm including the number, and my arrow would point to the right. On example 2, to get x by itself, what I would do is I would divide by negative 6, since negative 6 is multiplying x. X is now by itself. 18 divided by negative 6 is negative 3, and since I divided by a negative, that means my inequality sign has to reverse for a solution of x is greater than or equal to negative 3. If there's more than one step, you're going to use reverse PEMDAS to get your variable isolated, and remember, if there's variables on both sides, you want to collect those variables on one side before you continue. Pause the video, try examples 3 through 6, press play when you're ready to check your answers. So on example 3, I'm going to use reverse PEMDAS to get x isolated by first adding 7 and then dividing by 3. For a final solution is x is less than 5. I never divided or multiplied by a negative, so I don't have to worry about reversing the inequality sign. On example 4, the first thing I want to deal with is the fact that I have variables on both sides. So remember that to collect variables on one side, we can either add or subtract the variable term over. I chose to subtract 3x to make it cancel, and then I had to do this on the other side as well. This gave me a new inequality of 2x minus 12 is less than or equal to negative 4. Don't forget about that negative sign. And then added 12 to both sides and divided by 2 for a final solution of x is less than or equal to 4. On example 5, reverse PEMDAS, we're going to start by subtracting 2 from both sides. Negative 5 minus 2 is negative 7. Then dividing both sides by negative 7. Since I'm dividing by a negative, I need to reverse my inequality sign for a solution of x is greater than 1. On example 6, I begin by bringing my variable term over to join the other one by subtracting 2x from both sides. 4x minus 7 is greater than 17. I then added 7 to both sides and divided by 4 for a final solution of x is greater than 6. On example 7, I would begin this problem by distributing my negative 1/4 to my parentheses. So I would get negative 1/4 p, negative 1/4 times negative 12 would be positive 3 is greater than negative 2. Now even though I'm distributing a negative, which is multiplying, it's not something I'm doing on both sides of my inequality, so I don't have to worry about reversing the sign. My next step would be to subtract 3 from both sides, which would get me the new inequality of negative 1/4 p is greater than negative 5. And then to get rid of the negative 1/4 p, I could multiply by its reciprocal of negative 4. Now I am multiplying by a negative, so at this point, I need to reverse my inequality sign, and negative 5 times negative 4 is positive 20. My solution is p is less than 20. Pause the video to try example 8. Press play when you're ready to check your answer. So on example 8, I began by distributing my negative 0.6, which got me negative 0.6x. A negative times a negative was a positive. The way I did this without my calculator was I said that 5 times 6 was 30, and then 1 decimal place to get 3. I then subtracted 3 from both sides, and then my last step was to divide by negative 0.6. Again, you could use a calculator. I actually ended up setting it up as a fraction. So I divided 12 divided by the fraction equivalent of negative 3/5, but I know that dividing by a fraction means multiplying by the reciprocal. I was then able to cancel my 3 into my 12 to get a 4 for a final answer of x is greater than or equal to 20. I also had to remember to reverse my inequality sign since I was dividing by a negative. So we're going to do some graphing on these ones. just to see what happens when the variable is on the opposite side. So we'll do example 9 together, and then you'll try the remaining examples on your own. So on example 9, my goal is to get x by itself. It's being divided by -4, so to undo that, I would multiply both sides by -4. I now have x by itself, and I know that -4 times 12 is -48. But since I multiplied by a negative, my inequality sign needs to reverse. Now if I were going to graph this, I know that I want to start at the number -48 on the number line, and when I set up my numbers, I'm going to make sure that they would go in number line order. I would have an open circle, and the key on this is knowing which way my arrow would point. Should it point to the right or the left? The way I would figure that out is I would start by reading from the x. And if I read this way, what it really says is that x is less than -48. Even though looking at the inequality sign, it might look like greater than, I'm always reading starting with the variable first. So x is less than -48, which means that when I graph my arrow, I'm going to point to all the numbers that are less than -48, which are to the left. Try examples 10 through 12. Pause the video, press play when you're ready to check your answers. So on example 10, to get m by itself, we would multiply both sides by -7. Since we're multiplying by a negative, our inequality sign is going to reverse. It's really important with inequalities that you don't just move the variable to the other side. If I wanted to at the end here, what I could do is I could turn the entire inequality around and make it say m is greater than -112, but I haven't really changed it. The open side of my inequality is still facing my m in both cases. In equation, you can kind of move the variable, but for right now, we want to kind of keep things where they are. If I were to read this, starting with the variable first, it says that m can be greater than -112, which is why my arrow would point to the right. And an open circle shows that I'm not including the -112 as part of my answer. On example 11, I just had to divide both sides by 5. 5 is positive, so I don't have to reverse my inequality sign, and this just says that b can be less than or equal to -9. Close circle, arrow goes to the left. On example 12, dividing both sides by -6 would get n by itself. Because I divided by a negative, I need to reverse my inequality sign, and 24 divided by -6 is -4. If I were to read this starting with the variable first, it says that n can be greater than or equal to -4. I want to include -4, so I'm going to use a closed circle, and I want to point my arrow to the right. So in word problem 1, we're selling bows again. This time we're only selling large bows for $5 each. Our hope is to save at least $1,800, and we already have $500 saved in our bank account. We're going to write and solve an inequality to figure out how many bows we would need to sell in order to meet our goal. So the thing that I don't know is the number of bows that I'm selling, so I'm going to go ahead and call number of bows X. I know that I already have $500 in my bank account. In addition to that, I'm going to make $5 per bow. Now that's going to give me, these two amounts added together would give me my total amount of money. And since I'm trying to make at least $1,800, I want that amount to be greater than or equal to $1,800. Now I can solve this inequality, and the first thing that I would do to solve this inequality would be to subtract 500 from both sides, since I'm going to reuse reverse PEMDAS. And this would give me that 5x needs to be greater than or equal to $1,300. Now what this would mean is that I still need to make $1,300, and I'm going to figure out how many bows it would take to make that happen. I'm going to divide both sides by 5, which would get me that x can be greater than or equal to, 5 can fit into 13 twice with 3 left over. I believe it would be 260. So I need to sell 260 bows in order to make my goal of $1,800 or more. In this final word problem, a gas station charges 10 cents less per gallon if a customer purchases a car wash. I can see on the sign that gas costs $2.09, but my problem tells me that I'm going to purchase a car wash. It kind of jumped ahead there. So what that means is that I'm going to pay $1.99 per gallon. Now I only have $20 in my pocket, and so what that would tell me is that the most I can spend is $20. And it says I'm definitely going to buy a car wash, and a car wash costs, a car wash costs $8. Sorry about that. So that means that my total money spent, since I only have $20, has to be less than or equal to 20. Well, I know I'm going to spend $8 on the car wash plus $1.99 per gallon of gas. Now the thing that I don't know is how many gallons I'm going to buy, and so that's going to be represented by my variable. Now to solve this equation, I would use reverse PEMDAS, subtract 8 from both sides, which would get me $1.99. X is less than or equal to 12. I would then divide both sides by $1.99. Now, since I can just see that I'm dividing 12 by about 2, I should expect this to come to about 6, but I'm going to double check this on my calculator. And this came out to about 6.03 gallons. Now, if this were like apples or buses or something, I couldn't have 6.03 apples or buses, but you can have 6.03 gallons of gas, so that's totally fine. And what this would mean in terms of an answer is that I can buy up to 6.03 gallons of gas.